Good morning, students. Let's start with the laboratory preparation of normal and acid salts. First example is the iron chloride, which can be prepared by the direct combination of elements named as the process synthesis. For the preparation of your iron chloride, kindly check this diagram in which chlorine gas is being inverted into the flask which contain the concentrated sulfuric acid. The function of the sulfuric acid is to dry this chlorine. After that, this chlorine is transferred to the iron vial, which is the combustion chamber. In that combustion chamber, the heating is being provided from outside. As the heat is supplied, the reaction becomes exothermic. After that, the heat is being suspended. When the reaction is done between the iron, which is being formed the red hot after the heating, treat with the chlorine, there will be a formation of the iron chloride, which is being transferred to this conical flask in the solid form. This solid iron chloride had the property of the Dalisquent nature, which can be dried by the drying agent that the fused calcium chloride. Now check the reaction. Iron plus 3 molecules of the chlorine. That chlorine will be dry with a concentrated sulfuric acid and iron should be heated externally. There will be a formation of iron chloride. Here one very important point is that we can't directly heat the iron chloride. The reason behind is that when the iron chloride hexahydrate is being heated, it will decompose into the Fe2O3 with the 9 molecules of water and 6 molecules of HCl. That's why we have to do that procedure. This anhydrous iron chloride is formed with the help of the drying agent, that is calcium chloride, is used in the catalyst in certain reactions. After that, the second preparation of the copper 2 sulfate, named as blue vitriol in their hydrated form. For the preparation of the copper sulfate, we have to take the dilute sulfuric acid on an insoluble base, maybe copper hydroxide, copper oxide, or copper carbonate. When we are taking either of that one compounds and treating with the sulfuric acid, you can check from the first three reactions, there will be a formation of the copper sulfate with the water molecule, except in the third reaction where the carbon dioxide is also forming, because the carbonate salts always form the carbon dioxide, which turns lime water milky. Now, how the procedure is going on? First of all, we have to take the dilute sulfuric acid in a beaker, heat it properly with the help of the wire gauge. After that, in another beaker, we have to take the copper hydroxide, approximately 5 grams. That copper hydroxide is inserted in the beaker of sulfuric acid with regular stirring up to and until the saturation of that compound is not reached. It means it should dissolve as maximum, and after that excess of compound will settle on to the bottom. Filter that compound in your hot form, then collect the filtrate in a china dish. That china dish is again being heated up to its crystallization point, but boiling should not be there in that china dish. it will rupture your crystals and exceed your crystallization point. Then stop heating and allow to cool it on the water bath without disturbing. What you will see in the step number 4, it is clear. You will see the bright blue color crystals of copper sulfate pentahydrate, which is further on dried with the help of a filter paper. Many other salts like zinc sulfate, lead sulfate, calcium chloride, calcium nitrate, and magnesium nitrate or sulfate can be prepared by this method. Next preparation is the zinc sulfate and iron sulfate. One by one we will be doing that. Zinc sulfate is being prepared with the help of a metal that is zinc. Why? Because zinc is very active metal. When you treat with the sulfuric acid, you can check from the reaction. When you treat with the sulfuric acid, it gives zinc sulfate with a hydrogen gas. We have to do in a detailed form how experimentally we are doing that. First of all, again, we are taking the dilute sulfuric acid. The ratio should be 1:5. Heat it on the wire gauge. After that, add some zinc that is in the granulated form. Granulated zinc pieces with regular stirring. A point will come when the zinc will settle down and effervescence start there, or in the second way, for the effervescence, we are saying the bubbling is there. That means the hydrogen gas is being liberated. One is this way. Another way is that insoluble salt can be prepared by taking the solution of 2 appropriate salts. Condition is that in that appropriate salts, the required ions should be there. After the treatment, the solid precipitates will form, which can be filtered, then washed and dried. Next example, that is of lead chloride. When we are treating the lead chloride with a sodium chloride, for the preparation of lead chloride, the reactant we have to take it, or at starting we have to take the compound that is lead nitrate and sodium chloride. In place of the sodium chloride, we can take the hydrochloric acid also. We have to mix it, dissolve it one another. After doing that, filter it. The second step is to filter it. The filter purpose is to remove the impurities. When we get the filtrate, transfer that filtrate to the china dish and heat it regularly with regular stirring and no boiling. Again, at that moment, the crystallization point came and we have to check that point. At that moment, stop heating and place your china dish on the water bath without disturbing it. Cool it and you will get the crystal of the lead chloride. For the reaction of the lead chloride, lead nitrate treating with your hydrochloric acid, formation of the lead chloride with the nitric acid. Both the ways can be possible with the hydrochloric acid and sodium chloride is there. In that process, the pure needle-shaped crystals, the shape of the crystal is needle shape, we can observe here. The chlorides of the lead, silver or mercurous and the sulfate of barium, lead and calcium can also be prepared by this method. Next process, that is of calcium carbonate. Here for the preparation of the calcium carbonate, we have to take somewhat different process in which we are taking the hot solution of the sodium carbonate, hot solution of the sodium chloride with the sodium carbonate, resulting into the calcium carbonate in the white precipitate form with salt, that is your NaCl. When these precipitates are formed, we have to filter it, washed it, and dried it. When we dried it, it means the amorphous powder of the calcium carbonate is formed. By this process, except sodium, potassium, and ammonium, all carbonates are being prepared. Next preparation is the preparation of the sodium bicarbonate, that is an example of the acid salt. Here somewhat the process is different. First of all, we have to take the sodium carbonate crystal in this conical flask, which had two delivery tubes, one for the inlet and one for the outlet. That conical flask is placed in a trough containing the ice. Carbon dioxide is being injected from the delivery tube into that conical flask, and that sodium carbonate, with the help of the water coming from the ice, reacting with the carbon dioxide, leads to the formation of your sodium bicarbonate. In that one, check it this diagram properly. In this conical flask, we are taking the sodium carbonate crystal. Carbon dioxide is being injected. Ice is present outside due to the freezing mixture, so that we can cool it properly. Sodium carbonate react with the water and carbon dioxide, leading to the formation of your sodium bicarbonate, which can be collected afterward. Next preparation is of that salt which leads the process of neutralization. Neutralization is that process in which the different examples we have to take it. When one base is being treated with the acid, there is a formation of salt and water. Like that one, salts we are taking in that. The common thing in that salts is that under the ionic equation, kindly check the ionic equation of the sodium hydroxide. Sodium, Na positive, OH negative, H positive, Cl negative, give rise to Na positive, Cl negative with the water. Check it to the reactant and product side, both Na positive and Cl negative is present. We are cancelling it. Afterward, we are getting OH negative plus H positive give rise to water. It means water is forming in the process of the neutralization. You can check it from this one also, this your reaction. Or hydronium ions with a hydroxide ion give rise to your water molecule. The number of molecules of the water molecule is more in that case. By that process, heat is liberated, which is called a heat of liberation or heat of neutralization. Next is your Preparation of the sodium sulfate, very, very important process under the your neutralization, where the caustic soda is being used with the dilute sulfuric acid. Caustic soda had the formula NaOH is there. Treating with the dilute sulfuric acid, when sodium hydroxide is diluted, you're treating with the dilute sulfuric acid, there will be a formation of the sodium sulfate with the water. But this method is leading a process that is titration. Titration is somewhat different from the earlier processes in which the required amount of acid is being taken in this burette. This one is burette. And required amount round about the 20 ml or 25 ml of the sodium hydroxide is being taken in this one, your conical flask. It is being pipetted out. After adding the sodium hydroxide solution in this one, we are using an indicator, 1 to 2 drops in this. Setting the apparatus like this. From the burette, by the opening of the stopper should be settled as it, that the drop while drop, your acid is coming here in the conical flask. One condition is there, the regular stirring, which will lead to change of color of the solution. And when the color of the solution is changed, it means it is an end point. We have to check then the initial reading and the final reading at which the color is being changed. The difference in the initial and final reading leads to our answer how much amount of the sulfuric acid is being used to required amount of alkali. That amount is being then treated, evaporated by the same process, and the crystal of sodium sulfate decahydrate is being formed. That is not necessary that the only sodium hydroxide we have to use it. We can use it the sodium carbonate also by this process. But when we are using a sodium carbonate, then the indicator is being changed, that is a methyl orange. Another point, the ratio of the both sulfuric acid and sodium hydroxide should be in the proper scale. Otherwise, the complete neutralization will not occur. That is required for preparation of that. Next concept, how we can prepare the sodium bisulfate from the sodium sulfate. The process is very easy. As it is, do the process that the sodium hydroxide treating with the sulfuric acid, there is a formation of the sodium sulfate. In that sodium sulfate, add twice the acid. Result, acid salt. It means then when the acid amount is more than your base or alkali amount, then the acid salt is forming. That is all for your preparation of salts, that is normal and your acid salt. Thank you and have a nice day. In the next lecture, we will do the different processes, different terms, and your exercise. Thank you.